Yesterday we were graphing sine and cosine functions. What's the sine song? Middle, high, middle, low, middle, very good. And what's the cosine song? High, middle, low, middle, high. You didn't sing. Everyone else did. Okay, thank you. Very good. So today we're graphing tangent. And we learned yesterday that we can have period changes on sine and cosine, and we can have amplitude changes as well. And so we graphed some functions yesterday. And today you're going to be asked a few more questions about graphs like this that might appear. There's a couple of different ways that you can just look at the graph, so no equation, right? What's the amplitude of this function? 5. That's pretty easy to see when the graph is like this. But what if you had a graph that was like, and 42, and it looks like this, something like this. So this is what you saw. And so let's pretend this is the only thing you saw. What's the amplitude of this function?
42.
Okay, 6 is the correct answer. Why? It's in the middle, so the maximum here is 42, and the minimum is 30. The amplitude talks about the distance from the middle to the highest point. So there's a couple of different ways we can figure it. So Will, how did you get 6?
It's like 12 divided by 2, or you can just go from 36 to 42.
Okay, so first you said 12. So where did the 12 come from?
The whole 42 minus 30.
42 minus 30, yeah, top minus bottom. So 42 minus 30, that's the difference between the max and the min, okay? And then, so that gave you 12, and then you said I have to split that into 2 equal parts because there's an amplitude up and there's an amplitude down. So it is, to find the amplitude, one way to do it is to subtract the high and the low, and then divide it in 2. And so that gives us 6, all right? And so there's a lot of ways you can think about it, but, you know, what's between 42 and 30? Well, 36. So you might think about it like that, and that difference there is 6. So to go from 36 to 42 is 6. So lots of different ways to think about it. But yeah, don't just think the amplitude is not 42. So that you gotta think a little harder than that. Okay. So you'll see that today. Today we're going to be graphing tangent functions. And so now, again, we're starting from the unit circle, just like we did yesterday. And we have to figure out a few things here. So just like yesterday, we have our horizontal axis. The horizontal axis is our radian measures as we travel around the unit circle. So we're starting at 0 radians, so right here at 0, and then I'm just going to keep walking around the unit circle until I start to see a pattern. And so once again, we have 0. What's my dot up here? Pi over 2, pi, and 3 pi over 2, and then 2 pi all the way around. So I'm going to go ahead and mark those out here, a nice even 1, 2, 3, 4. I'm going to do that a couple of ways. So this is pi over 2, and pi, and 3 pi over 2, and 2 pi. Can I go backwards as well? Maybe? Can I do a negative rotation? Can I do that as well? Can I go negative pi over 2? Is that okay? Negative pi over 2? Yeah. And then negative pi in reverse, so negative 3 pi over 2. I'm going to do that just so, that's for tangent. Okay, so now as I'm walking around the unit circle, of course we have our ordered pairs. So right here is the ordered pair 1, 0. Up top, what's the ordered pair? 0, 1. To the left is the ordered pair negative 1, 0. And at the bottom we have 0, negative 1. Awesome sauce. Okay. So, but now what we're graphing is we're graphing the tangent functions. Y equals the tangent of our angle x. How do we get a tangent ratio? Yeah, so tangent of our angle is the y coordinate. Oh, tangent of theta is y over x. So that was from our unit circle. So get tangent, we did y coordinate over x coordinate. And so at 0, tangent would be 0 over 1, which is 0. And then at pi over 2, y over x would be 1 over 0. Oh, undefined. What happens when we get something undefined? An asymptote. Yeah, we get a vertical asymptote right there at pi over 2. I need a point in between, actually. So, okay, so right here is friendly pi over 4. Pi over 4 is right in between 0 and pi over 2. What's the ordered pair at pi over 4? Yeah, radical 2 over 2 and radical 2 over 2. So now, if we do the tangent ratio, tangent would be radical 2 over 2 over itself, which is 1. Radical 2 over 2 divided by itself is 1. So at pi over 4, we get a value of 1. All right. Okay. Let's keep walking around the circle. Oh, I guess I need to do 3 pi over 4. 3 pi over 4 is right here at 135 degrees. What's that ordered pair? Good. Negative radical 2 over 2 and positive radical 2 over 2. And if we did tangent y over x, that's going to be negative 1. Yeah. Oh, so at right here is 3 pi over 4. That has a value of negative 1. That's interesting. Okay. So that's negative 1. And then if I go to pi, y over x, 0 divided by negative 1 is 0 again. So at pi it's 0. Okay. All right. This is kind of interesting. Right here, 1 pi over 4, 3 pi over 4. This is 5 pi over 4. What's the ordered pair at 5 pi over 4? Negative rad 2 over 2 and negative rad 2 over 2. And y over x is 1, positive 1. So now at 5 pi over 4, I'm at positive 1 again. And then down here at 3 pi over 2, y over x, negative 1 over 0 is undefined. So at 3 pi, at 4, 2, oh, okay, I have a, okay, something is repeating. My asymptote is repeating. Okay, so what does this look like? Will you please grab your calculators and type in to y equals, go to y equals. Yeah, we got asymptotes. Will you go to y equals and type in tangent of x? And then will you do zoom trig? Go to your calculators and y equals, type in tangent of x, and press the zoom button and do zoom trig.
Oh, that's pretty.
Zoom trig.
Would you like my calculator?
Yeah, thank you.
Well, mine does.
Zoom trig. All right. So this is Zoom. The Zoom trig menu is a great menu for when you're graphing trig functions. It sets the window. If you look at the window, it's a little bit over 2 pi and negative 2 pi. So it's just a really nice window. It has a pi over 4 step for each tick mark. But you can see right here we've got an asymptote. So what's happening is that's our asymptote here at pi over 2. So our tangent function is this increasing function. It's increasing, starts on the left side of the asymptote and grows towards the right side. And it has asymptotes at every pi over 2 and 3 pi over 2 and 5 pi over 2, 7 pi over 2. Do you hear a pattern there? Odd pi's over 2, yeah. And so it has it has asymptotes that are odd multiples of pi over 2. So like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and positive or negative as well. So there's another asymptote at negative pi over 2, would also be that vertical asymptote. And at negative pi over 4, we also have a dot here at negative 1. So we have this. Okay, so here's our tangent function, and just sort of repeats, passing through pi and then asymptote. All right, now I think of tangent as toes to nose. I don't know why. It starts low at your toes, and then it increases to the right to get to your nose. Toes to nose, that's tangent, T-A-N, toes to nose. You're connecting the dots I'm throwing out at you. It's kind of weird, right? Tangent, T-N, toes to nose. Okay, so it starts low inside, so it's an increasing function. You good with that? Yeah? Okay. All right, so it has asymptotes at pi over 2, all these multiples of pi over 2. We don't really discuss amplitude with a tangent function, but we do have some nice points. Like it does pass through pi over 4, 1, and negative 1 at negative pi over 4. So there are some nice points that still can be stretched pretty easily, okay? And so we can do that. Now, what is the period of this function? How long does it take for it to repeat? Pi over 2, yeah. Well, is it just pi over 2? So, yeah, from negative pi over 2 to positive pi over 2, that is one period. But how long is that? What is the distance between those? It is 1 pi, yeah, it is 1 pi actually. Here's another one at 3 pi over 2 is another asymptote. If we want to find the distance between these, we just have to subtract. 3 pi over 2 minus 1 pi over 2 is 2 pi's over 2, which is just pi. So the period, the time that it takes for it to repeat itself, has a period of pi. So a standard tangent graph has a period of pi. What happens if we put a number in front of that x? How does that change the period? Yeah, it's going to stretch or shrink it this way, horizontally in the x direction. And so just like yesterday we did 2 pi divided by b, today a normal period is pi. And so we have to divide pi by whatever that number is in front of x if we want to work out the graph for this guy. Okay. So let's graph a couple of these so you can see what's going on. We want to identify the period and show the asymptotes and graph these. So again, this has a vertical stretch of 4. We are graphing a tangent function, and right now, what is the period? Just pi, yep. So it's pi over b, and in this case, that b is 1. So our period is just pi. And our normal tangent function then has asymptotes at pi over 2 and negative pi over 2. So I'm going to draw those asymptotes in. Those are things you want to remember. And I know it passes through 0, 0. And again, you don't really have to remember it so much as, you just think about your unit circle, tangent is 0 over 1, we get 0 at 0. And then I know it goes toes to nose. Normally at pi over 4, it would equal 1, but we're multiplying our function by 4, so it's no longer a 1. What does it stretch it to? 4, yeah, so it has a 4 now. Pi over 4, 4, and negative pi over 4. How low does it go? Negative 4, yeah. So there we go. This is one period of our tangent function. And that's all I care about. Could you graph this on your calculators?
Probably.
Yeah, probably. But let's go and try the next one here. You'll notice I squeezed in a pi here because I wanted it to be a little different. So this is negative tangent of 1/2 pi x. So this is 1/2 pi x. What's the negative going to do to my toes to nose graph? Flip it! Yes, so it's going to flip it and become a decreasing function. How do we figure out the period? Pi divided by 1/2 pi, which is a little bit weird. What's going to happen with the math there? The pi's are going to cancel out. Oh gosh, I totally goofed on this. I'm sorry. You are right, the period is 2. I have to tell you something else. I want to figure out where my asymptotes are. And so in order to figure out where my asymptotes are, I'm going to compare it to what they normally would be. This 1/2 pi x would normally have an asymptote at plus or minus pi over 2. So what I'm going to do is I get to set up this little equation, and it's going to help me figure out where my asymptotes are, which is kind of nice. I can go ahead and solve for x. How do I get rid of this 1/2? Times by 2. I would like to do that. So I'm going to times both sides by 2. All right. All right, well, that's kind of nice. And then I have pi x equals plus or minus pi. All right, and then how do I get x by itself? Divide by pi? Yeah. All right, so I'm going to set up an equation to help me find these really nice points. What happens with pi divided by 5? Cancels out to become 1. Okay. So here we go. So this is where my vertical asymptotes are, right here at plus or minus 1. So this is a nice little equation we can set up every time to help us. And the nice thing is, I don't think I asked you to actually graph these, but here we go. So at 1 and negative 1, I have some vertical asymptotes. Normally it goes through 0, 0, so that's nice. And normally it goes toes to nose, but what does the negative do? Flips it. So it's going to have a max or a point through 1 and negative 1, but it's going to start up high this time and go low. What is this x coordinate here? Yeah, it's halfway between negative 1 and 0, so negative 1/2. And right here, again, halfway between 0 and 1 is 1/2. So now it's high to low. We're going downhill on this function. Again, it's kind of nice. You can check negative tangent of 0.5 pi x. And I can set my window to be identical to what I have here. So my x-axis can go from negative 1 to 1. And then I'm going to set my step to be 1/2. My minimum is negative 1, and my maximum is positive 1 on my y-axis. And I can graph it. And there we go. There's a great graph. I can zoom out a little more if I want to, so you can really see negative 5 to 5. And you can see that it would look pretty similar to my graph that I've drawn there, okay? What's going on over there? All right. So number 13. What's the period? Yeah, pi over 2. And again, I want to figure out where my vertical asymptotes are. What should I do? 2x equal to plus or minus pi over 2, where the normal asymptotes are. And how do we get x by itself? Divide by 2. Can I also multiply by half? That's the same thing, right? It's just a little easier when I'm dealing with fractions. What's pi over 2 times a half? Pi over 4, yeah. So here on this graph, I have asymptotes at pi over 4 and negative pi over 4. Whoops, positive pi over 4. So there's my asymptotes after they've been adjusted. My tangent graph goes through 0, 0. I'm going to call it amplitude, even though we don't really. What's my amplitude? Yeah, 5 over 2 and negative 5 over 2. What are my halfway points here? Pi over 8 and negative pi over 8. Very good. All right, and again, tangent goes toes to nose. So I've got my low point at negative pi over 8 and negative 5 pi over 2, and nose, my high point, at pi over 8. And it just keeps repeating. Repeating. Yeah? Are you okay with that? Yeah? You good? That's how we're doing. That's how we're doing today. It's not. It's Delta Math today. Oh, hey, great. Oh, oops. Thanks, Scott. Oh, wait, oops. Sorry, I gotta fix it. Wait, don't start yet. Hold on, wait. Okay, good. Now refresh. Forgot to change the date. Yeah.
To Mr. Redwine, get a paper and turn it into Mr. Barlow.
Yeah, that's fine, I think.